Welcome back to the Global Greek Influence, the podcast that takes you on a journey through the dynamic world of global Greeks in the realms of technology, cutting-edge scientific and engineering innovation, entrepreneurship and business, also special topics on politics and history. I'm your hostess, Panagiotou Pimenidou, and I'm thrilled to have you join us once again. If you want to stay updated and never miss an episode, make sure to subscribe, like, and review the Global Greek Influence podcast on your favorite podcasting platform such as Spotify, Apple Podcasts, Amazon Music, Google Podcasts, and more. Your support means the world to me. For even more engagement, be sure to follow our podcast's Twitter account, Facebook page, and LinkedIn page. It is the best way to stay up to date with the latest episodes, connect with me directly, and even suggest topics you would love to explore. But wait, there is more. For just €2.99 a month, you can unlock a world of exclusive content. By becoming a premium subscriber, you will gain access to exclusive video episodes available only on Spotify, get sneak peeks of upcoming interviews, and enjoy special episodes that dive deep into fascinating topics. So get ready to immerse yourself in the captivating stories and influential figures that have shaped the global Greek influence and impact the world today. Join us on this exciting journey of discovery and celebration. Thank you for being part of the Global Greek Influence community. Digital twins contribute to the continuous improvement of processes by enabling organizations to continuously monitor and improve their processes over time. Organizations can identify trends, patterns, and opportunities for optimization by capturing real-time data. This continuous improvement cycle helps organizations stay agile, adaptive, and responsive to changing market conditions, leading to sustained process efficiency. Digital twins present various complexities when navigating the challenges and opportunities for process efficiency. Some of these complexities include data integration and management, model development and validation, scalability and complexity, real-time monitoring and control, cybersecurity and privacy, system integration and interoperability, change management, and organizational adoption. Today, I'm with Nikolaos Sarantinoudis, a researcher on the Industrial and Digital Innovation Research Group called IDIGO at the Technical University of Crete in Greece. Nikos, with his colleagues at the Industrial and Digital Innovations Research Group, a multidisciplinary team of researchers, engages in research and academic activities at the School of Production, Engineering and Management. The group performs applied research and development that crisscrosses four pillars: process engineering, circular economy, environmental engineering, and digital innovation. Nikos graduated with an MEng, a Master's of Engineering in Electrical and Computer Engineering from the Technical University of Crete with a thesis on autonomous navigation of an electric vehicle. Then he worked as a research associate for a feasibility study in partnership with IPFT Fuels Ltd in the United Kingdom on a new and innovative idea of electric vehicle charging with a use of a robotic arm. Nikos continued as a postgraduate research student at the University of Surrey in the United Kingdom, working on sensor fusion and digital map construction for autonomous vehicle navigation. He then focused on the fusion of camera systems and LiDARs, which stands for light detection and ranging, and refers to a remote sensing method for detection and classification in unstructured environments. Before Nikos moved back to Greece to start his PhD at the Technical University of Crete, he worked at IPFT Fuels Ltd on the product development and integration of a prototype for an innovative autonomous electric vehicle charging system expected to connect to the undercarriage of a vehicle. With Nikos, we will discuss today how digital twins can optimize processes, including those in electric vehicles and the chemical industry, and improve the supply chain. Also, Nikos will discuss his vision of future research, including machine learning, how a researcher or a PhD candidate fits or not into today's academic environment, and how else a researcher or a PhD candidate can contribute to knowledge transfer. Welcome to the show, Nico.
Hello. Thank you very much for having me on the show, and thank you very much for the introduction. So you briefly mentioned what I have done until now, so that's a quick wrap up. So also from my side, as you said, I'm an electrical and computer engineer. I graduated from the Technical University of Crete. And after spending some time abroad in UK, to various positions, I came back. I'm now working as a researcher, and at the same time, I'm performing my PhD on the digital twins and the construction of an application framework in order to combine digital twins technologies with autonomous systems. So we're definitely going to discuss more about that later. And as you said, I'm part of the Industrial and Digital Innovations Research Group, where we mainly work on European research and innovation projects.
Most of us have heard that electric vehicles will become our primary transportation, backed up by renewable energy. Electric vehicles may have higher energy consumption compared to conventional vehicles for several reasons. Battery technology, vehicle weight linked also to aerodynamic resistance, driving style and conditions, and charging efficiency, which can improve as renewable energy sources become more prevalent and advanced charging infrastructure. The environmental impact of electric vehicles charging can be minimized, yet it remains an issue. How can electric vehicles' energy consumption improve?
So let's see. First of all, I think we all know what nowadays electric vehicles are very, very famous, and they are getting more and more into our lives. So from my experience, I've worked quite a lot with vehicles through my previous years, and I can give some hints and tips on how we think that the electric vehicle energy consumption can improve. So the first thing that someone can do is basically to optimize and to adjust their driving settings. So either that can be done from the driver, from the way someone is driving and how they behave with the vehicle, or it can be also done, let's say, automatically or through like a smart technology and AI, or we can call it whatever we want. But it's a technology that can help us support the driver, like an it's something like we can call it an advanced driver assistance system. So, for example, nowadays we see systems that they can keep us into the line, or they can brake if we have an emergency. So in the future, we can have a similar system that can help us adjust the vehicle settings to the optimal ones in order to have the best energy efficiency. So what else we can do? So if we think about digital twins, and this is something that we're going to hear a lot today, and we're going to discuss on that. So an idea would be to have a digital twin of an electric vehicle, and that will help us in real time adjust these settings. So not only having, let's say, a dummy system that has some predefined settings like the sport mode or eco mode or something like that, but we can have a system that will in real time read information from the vehicle, from the sensors, do some calculations offline or in the cloud or some optimization, and then adjust the settings according to each trip of the driver. Another thing for the EVs, for the electric vehicles efficiency, is something that we all should understand, and nowadays more and more, because at the end we'll all drive electric vehicles at some point, to understand how we should drive this car. So that is basically teaching the user. And what do I mean by that? I mean that you have a driver's license. That's not what I mean. I mean in order to find out how someone should drive an electric vehicle, because it's not the same as the vehicles that we all know. For example, electric vehicles have technologies such as the one pedal drive system. So if we go very slightly on what this is a way to drive the car without using the brakes. So the regenerative braking from the electric motor can help you get back quite a lot of energy to recharge your battery. So you save up on the energy required for recharging. So this is something that should be taught to the users. Another thing that we can do is to, for example, fine-tune the navigators or the GPS or whatever we have every day, to understand that a vehicle is electric, because maybe a slightly longer route, but that have more like inclinations, could help us retrieve quite a lot of energy, and it will add like very, very few time to our trip, but it will have a very big impact on the energy efficiency of our vehicle. And lastly, as you also said, the technology on new batteries with different chemistries will be definitely also able to improve the energy consumption.
You focused in your research on digital twins, and many, not just researchers in other fields of study than yours or your groups, even graduates from engineering and science departments might have heard of digital twins, but let's say here that digital twins are virtual representations of physical objects or systems, and by simulating and analyzing the behavior and performance of products and processes, digital twins enable informed decision-making. So what is the impact of digital twins on promoting resource efficiency in a circular economy? Because one might not really link the idea of digital twins being a virtual representation of a physical object or a system, while simulating and analyzing data of behavior, performance of products and processes.
Digital twins, as you said, they are used in quite a lot of different areas. And how you describe them is exactly what it is. And it's very easy for someone to understand. But what it's not very easy to understand is how we're going to use them, as you said, in the process efficiency and in the value chain and the supply chain. The application of this technology provides us insights into, for example, a process industry, if we focus on the industry, because the digital twin technology is something that arises from the industry after Industry 4.0, and it became a concept in the near years. So now we are more focusing on applications of DTs in other domains, for example, me personally, on autonomous systems, but we need to understand what they can offer in the process industry, for example. And what we can say is that a digital twin is not exactly something new, but it's rather a compilation of things that we have already seen in the past under a new name that also help us to have them under a common roof, and then we can access all the things from the same point. So, for example, we can see the digital twin, the representation, that is basically process modeling and simulation. And then on top of that, we add the connection with the system, which is real-time information that come from sensors. And on this information from the sensors, we can perform data analysis and do prescriptive analytics or descriptive analytics or predictive analytics, different types of analytics to find out what is going to happen or what has happened in our system. And again, using this data, we can perform and apply some optimization algorithms and find the optimal settings and help the engineer or the process engineer set up the machines correctly. So the DT is like a compilation of things that can help us in things that we already did, but now we can do them more efficiently. I think maybe if I give an example from a project that we have already done, it might help to understand how the efficiency can be helped with the use of a digital twin, of an overall digital twin. So a past project that finished like 1 or 2 weeks ago, we had the final review with the European Commission. It was called FactLog. And the main idea behind that was to have energy aware digital factories. So focus, and it's something that you will also probably find interesting because it's about LPG production. And I know as a chemical engineer, you're more aware of these parts. And they were talking about a big refinery that they are purifying LPG to keep it on specs in order to be able to sell it in the industry. So this is a very energy intensive process. And their main issue was that they could get easily out of specs at the final tank where they are accumulating the product from various processes. Because what they had to do is they were performing lab analysis every 2 or 3 days. So if they found out that they were off spec with a delay of 2 days, they had to overstress their machines to perform highly purified LPG in order to mix it with the bad one, if we can call it bad, and to keep the final product on spec. So what we did through the project is basically apply ADT there that has all the parts that we discussed before. They get the data from the factory. They were performing analytics to find where the issue was caused in which machine. And then they were doing some simulations to find out that if we keep with the current settings, we will end up after an X amount of hours off spec. So we are then calling the optimization service, tell us which are the optimal settings that will help us retrieve the problem in a certain amount of time and with the least amount of energy consumed. So that's how DTs could be applied in an actual problem. I mean, partially actual because we're talking about research at the moment, but is not in theory. We had real data, we performed real calculation, optimization, and everything, and we suggested to the process engineer what they should do to correct the problem.
Let's move on and see digital twins in their application, for instance, in intelligent autonomous systems, especially the fans of driving, the futuristic fans of driving, including Elon Musk. They are heavily investing in autonomous systems. Digital twins with autonomous systems integrate optimal control, monitoring, and decision making. One might ask if we have seamless communication, data exchange, and coordination between the physical system and its virtual representation. I will ask you, why is an application framework for digital twin-driven intelligent autonomous systems needed?
As we discussed, DTs are very popular. Autonomous systems are very popular. And these are two technologies that at the moment, they are not really connected. So this is mainly where the application framework is required. So we have two technologies that have progressed quite a lot in the recent years, and that they are now coming out of, they say they're in closure. They are not only used, for example, DTs are not only used now in factories. Autonomous vehicles are getting more well-known and are coming out of warehouses. So these two technologies growing, but we need to find a way to combine these two. So this is where the application framework comes. It will help definitely to find out the proper way to apply DTs in autonomous systems. It will give some guidelines. It will propose or suggest solutions that might come and might also puzzle, other researchers. And that will help things go faster and progress faster. Also, the application framework, if someone design it, or of course the community will add quite a lot of things to that, will also help industry to apply these solutions, because they will know that they will have something that's working, at least this application framework that might not be applying their specific problem, but is something that it has been designed, it has been proven that it's working, and it's helping them to basically boost their travel, their trip towards the integration of DTs and autonomous systems. So that's basically a wrap-up of why we need with a framework, because it's going to help us go faster to the intended direction and integrate with some guidelines. We can call it a map of how we can integrate two technologies that are existing right now into a single a new one that will help us add quite a lot of things into the autonomous systems.
Another term, or actually two other terms that are very popular these days, are machine learning and artificial intelligence. So one might ask, how different is machine learning from digital twins? Or if we talk about machine learning, which has subsections such as artificial intelligence and digital twins. Machine learning draws on knowledge and techniques from various fields, including computer science, statistics, mathematics, data science, and domain-specific areas like biology, healthcare, finance, and social sciences. If you think that machine learning should continue to exist as a dedicated field, as a standalone field, or should it be integrated into, for instance, the postgraduate curricula of other scientific and engineering disciplines?
So TTs are basically using machine learning. So they are exploiting the results of machine learning. So in the example that I gave you regarding the LPG production, the analytics that we call that they are taking place are basically utilizing machine learning in order to predict values or to find out where the problem has come. They are two domains that they are helping each other. And definitely when we talk about a digital twin, it couldn't exist without machine learning, because machine learning is very crucial for quite a lot of things right now, but it's also very crucial for DTs because the digital representation needs information. And most of the times, it cannot get all the information required from the physical system. So we may have some info that come from the flow in whatever system this is, but there might be not much information. So we might need machine learning to create some other data. And I'm not talking about artificial data, but I'm talking about data that we can basically calculate from the real data through machine learning. So they are very, very connected. And on the second part of the question that you asked me, so my idea on that is that we need to have a bit of both worlds. So yes, machine learning is a very generic term, and it's nowadays used everywhere. So it would be good to be taught as a specific thing in postgrads. So we can specify it in a finance, like an economics postgrad, how to use it in his own domain. For example, in my domain, how to use it in autonomous vehicles, and everyone should understand how to apply it on their domain. But we should also consider that some basics on machine learning and in the domain in general should be taught from on the undergraduate level. So if someone gets an introduction into machine learning from, like, we can call it young age, I mean in university terms, the second or third year, then it will be much easier for him to understand how to specifically apply this technology in his domain, his or her domain, of course. So it's the best is a combination of both worlds. So yes, it's very strange to say that we have someone that gets a master's in machine learning in general, because it's a very broad term, and it will be much more beneficial for everyone to get specific knowledge on how to apply this. But in order to understand, you have to get the background knowledge from an early stage in your career.
As engineers, we are quite accustomed, even those engineers that graduated from universities in the past 10 to 20 years, to produce simulations and modeling of various processes in our fields. So one might wonder how different is machine learning from the traditional modeling and simulation, because in modeling and simulation, we were writing algorithms as we do in machine learning applications, but we used different languages in a sense. That way we were writing these algorithms were dependent on the platform, on the software we were using. So how different is machine learning from what many engineers know traditionally through modeling or simulations?
It's a big difference. So it's something that can help us do things much faster. And the traditional way usually is by writing quite a lot of calculations through some first principle models that they need to be applied in the models that we have created, and they maybe need to run for quite a lot of time and perform millions of calculations to simulate a result. I mean, of course, part of doing things faster is the progress of technology. So we have much faster computers now. So of course, simulation is faster, and the same calculations will be done in a shorter amount of time. But the other big part is the application of machine learning. So it's much easier to build models that they find out, they predict a number, or they will calculate some values for us, because machine learning will do some things by itself. You need to also, to optimize the parameters, you need to build a network. But if you do also the pre-processing of the data correctly, then it's much, much easier for you to perform and create these models. A big part is the pre-processing of data, because if you feed crap to a machine learning, then of course not the expected result will come out. But it's very, very easy then, if you have the correct data, to create something very useful, much easier than by solving equations, differential equations, or stuff like that, that will take quite a lot of time. And yes, it was also programming, but in my opinion, it was quite more difficult programming to make a machine understand a differential equation, rather than make a machine understand how to build a network of neurons that will predict or give out a result for us.
And now you make me ask more questions. So what's the difference between machine learning and neural networks?
So that's something that's basically not different, but machine learning is the whole domain, and the neural networks basically is, if we can call it, how we see inside of a model that has multiple neurons. They are connected to each other, and they perform the calculations that we want based on some weights that we set and based on specific solvers. So you don't have to build your solver yourself. You are using ones that are existing, and you can also opt in different solutions to find which is the best one to give you the best results. And another part that just wanted to add is because it's not always black and white, so it's not either first principle models or machine learning. Another part that's gaining quite a lot of momentum right now is the hybrid models. So the hybrid models are basically combining the background knowledge that we have from the first principle models, because it's something that has been built over years, and we are sure that it's working, and the ease of the machine learning. So we get some information from the first principle models, we combine it with our machine learning, and that will definitely give us even better results by either one of these options.
International mobility for researchers is really important these days. We see that many researchers who want to develop themselves professionally and build collaboration networks, even enhance their own skills, their experiences, they tend to travel abroad and even stay abroad and follow an international career. Having won recently a Fulbright scholarship, I would like to ask you, and you also, of course, have this international experience in the United Kingdom as a research associate, both in the industry and the academia. In what ways do you view yourself developing as a researcher in terms of your professional trajectory?
So thank you very much for the good words on the Fulbright scholarship. So as you said, most researchers nowadays, they want to see something abroad. And in my opinion, it's something very good. You need to see how others are also working. You need to understand how things are done maybe differently, not always in a better way, but definitely they have good things and they might have bad things everywhere. But it's very interesting to find out how things are working abroad, how research is performed, how these worlds are, even though we're talking about academia, that might be quite different. So, me personally, I enjoy to do a PhD, but my future as a researcher and my opinion is that I will jump into industry. So it's something that you can do. We need to basically break this misconception that we definitely have in Greece, but maybe it's also in other parts of the world that if you do a PhD, then you have to become a professor. So that's of course not something that is true. Nowadays, quite a lot of industries investing in R&D, so they need people that they know how to perform research. They have dived deeper than the part of the masters, and that they are aware also on how to stick with the deadlines that they have discussed and talked with, for example, the European Union in our case, and we had the regular meetings, the reviews, and everything. So they have also these project management skills that they are required for someone that will be part of an R&D team in the industry. And me personally, I see myself jumping into industry, into R&D, because it's something that I really enjoy. It's something, research is a part that I really enjoy, but I would like also to apply it in an actual problem, because sometimes academia, as you said, might not have the means, or we might not have the way to do it in an actual system. So my future endeavors would be, after finishing my PhD, to jump into R&D in the industry.
Beyond your personal perspective for your future professional path, what is your insight on the future of researchers emerging from academia based on current trends?
So on that, the first thing that I would say is you need to find out what is best for you. So both paths are open, both ways are good. So you either want to stay in academia, then that's very good from your side, because you have the background, you've understood how academia works, you know how the research is performed in academia, and then you have your path to go if you want to become a researcher, or if you want to become, for example, a lab expert. It's a bit one way sometimes for quite a lot of people that they are into the Greek universities, that they will say, oh, if I do the PhD, I will stay in the university. But that's not something that you have to do. It might be easier because it will most likely someone will propose to you to stay in the university if you are already in the area. But it's something that you have to decide. So there is also quite a lot of solutions, not only abroad. So the ecosystem of startups and spin-offs is getting slightly better in Greece. So it's not like it is in the UK when I was, or in other parts of the world, but it's gaining momentum also nowadays. And there is a lot of spin-offs from professors that are trying to do things also in Greece. So that's something that also you need to consider. If you say that I don't want to go abroad, I don't want to go to find a company to work in the R&D, because at least from R&D, there are very few companies that are performing R&D in Greece. There is this solution that's something in between. So you have to also consider that if you want to escape, if we can call it escape, of course, from the academia, there is always the solution of a startup or a spin-off. And then industry is always looking for engineers, for skilled engineers that they know how to apply research and solve problems. So these, let's call them, like, it should be three different paths that they are equally easy to follow. But the main part behind that, and the main idea, is to understand what you would like to do. Because everyone is going to tell you that oh, academia is better, stay in academia, your professor. Or if you have someone from a company is going to tell you company is better, industry is better, come to us, we'll pay you more, for example, or something like that. But it's what basically you need to understand what is the good thing for you, not for the others. Or
One final question, Nico, before the end of our discussion. If a PhD candidate or a researcher find themselves in a group environment that does not suit them, what suggestions do you have for them?
Okay, so that's something I can answer from experience. So I had a similar situation when I was in UK, and I had started there a PhD that didn't go very well because they wanted to change my subject, and then there was a very big discussion on what's going to happen. So from experience, I'm going to tell you, and I know it's a very big and quite difficult decision to take, but you have to do what you enjoy. So basically, my suggestion is don't stay somewhere that you're not enjoying yourself, that you can't communicate, for example, with your supervisor or with your colleagues. It's the same thing as if we are working. We don't see it the same, but it's basically the same thing if we're employed somewhere. We find it much easier to say, oh, I will quit my job and find a new one. But quite a lot of people don't decide to quit a PhD and find a new one because they say, oh, I have spent some time, I have already invested some time. And yes, from experience, as I told you, I did the same. I spent some time, I invested time, but you're going to get more things that you understand when you take this decision. You'll get people that you stay connected with them, you get experience, you'll get many things, and these will teach you on how to behave and how to understand the next problems that may arise. So the path is open. There's always opportunities out there. So if you're not happy with what you're doing, my suggestion is try to find something that suits you and take the leap, and you will not miss, basically, because after looking at my decision after 3 years, I would say that it was the best that I could take at the moment. And yes, that gave me connections to the startup that I worked in UK, in the IPFT Fuels Limited. And then that gave me the idea to better formulate my current PhD topic, because I was clear that I can say that I want to do something on autonomous systems. And yes, I can connect with something that we're doing in the lab, but definitely I want to do something on the autonomous system because that's what I enjoy. And it's going to teach you quite a lot of things, even if it's a very big question. So be happy on what you're doing and don't worry about, worry, of course, but there is always a bright side on the things. It might not come immediately, but eventually you'll see the bright side.
Thank you, Nico, for accepting the invitation of the Global Greek Influence podcast and discuss in this episode your vision of future research about machine learning, digital twins, autonomous systems, and how a researcher fits or not in today's academic environment and to follow their dreams.
Thank you very much, Yota, for having me on Dr. Pimenidou, if I should say it correctly, or having me on the podcast. And it was very, very interesting discussing with you. And I was very happy to share my experience and my path until now, and my ideas also on how a researcher can solve some problems, or how someone in Greece or abroad find their next step. And of course, it was great discussing about technologies. So once again, thank you very much. And it was nice to meeting you.
Thank you all for staying until the end. Stay tuned for another podcast episode. To never miss an episode, subscribe and follow the Global Greek Influence podcast on Spotify, Apple Podcasts, Amazon Music, and 7 more podcasting platforms. Until next time. Thank you for being part of the Global Greek Influence podcast family. I cannot wait to bring you more exciting content in the future. Stay tuned and keep exploring the world of podcasts with a global Greek influence.